Hello everyone, welcome to my YouTube channel. I am Dr. Injimamul Haque, currently working as an assistant professor at the Department of Mathematics, School of Computer Science and AI, SR University, Warangal. In today's lectures, we are going to discuss a very important topic in statistics, hypothesis testing for variance of normal population. Now let me ask you a simple question. Suppose two machines produce the same product. Both have the same average output, but one machine is more consistent and other is highly variable. Which one would we trust? Exactly, the consistency matters, and that consistency is measured using the variance. So today we are going to learn how to test whether a variance is acceptable or not using some statistical tools. Okay. So now first we discuss why hypothesis test concerning the variance. In many statistical problems, we are interested not only the mean of population but also in the variability of the population. Variability is measured using the variance denoted as sigma square or the standard deviation sigma. A hypothesis test concerning the variance is used to determine whether the population variance differ from the specific value. For example, a manufacturer claimed that the variance in the diameter of the machine part is 0.04 millimeter square, right? A quality control engineer want to test whether the actual variance is larger than the claim variance. A school value administration want to test whether the variation in exam scores in a specific value. Such tests are important because large variance indicate inconsistency in process, right? So this is the concerning for the variance. So now we will discuss about the assumption for the hypothesis testing, right? For testing variance, the following assumptions must be satisfied. The first is what? The sample is randomly selected. The population follow a normal distribution and the observation should be independent. Okay. If the population is not normal, then the test may not be valid. Okay. So now we discuss about the hypothesis testing. Okay. For the variance. So now let the population variance be sigma square, right? Then what is the step for the hypothesis testing? First, step 1 will be what? Step 1, the hypothesis testing, right? Step 1 is determination of hypothesis, right? What will be that? First will be the null hypothesis. What? Null hypothesis will be what? H naught. This is sigma naught square equal to sigma equal to sigma naught square, right? And then we will decide the alternative hypothesis. Alternative hypothesis, right? Alternative hypothesis. Okay. So alternative hypothesis depending on the situation, right? If it is two-tail test, already we have discussed about the one-tail, two-tail test in the previous video. Two-tail test, if it is two-tail test, then the alternative hypothesis H1 will be what? Just the complement of this one, that is sigma square not equal to sigma not square, right? And if it is right tail test, if it is right tail test, then this H1 will be what? Sigma square is greater than sigma naught square. And if it is left tail test, then H1 will be what? Sigma square is less than sigma naught square. Okay, and here the sigma naught square is what? Sigma naught square is the claimed or is the claimed or hypothesized variance. Claimed or hypothesized hypothesized variance, right? So this is the step one. In step one, first we will determine the hypothesis, right? First we will determine the hypothesis as a null hypothesis and alternative hypothesis. Then in next step we will find the test statistics value, right? Test statistics. Test statistics. When the population is normally distributed, the test statistics follow the chi distribution. In case of variance, when the population is normally distributed, the test statistics follows the chi-square distribution, right? Chi-square distribution. And in this case, test statistics will be what? The test statistics. So the test statistics is what? Chi-square equal to n minus 1 s square by sigma naught square. Sorry, sigma naught square. Okay, so this is the, in second step we will find the test statistics value. Okay, and here here n is the sample size. N is the sample size. S square is the sample variance, and sigma naught square is the what? Sigma naught square is the claimed variance. Is the claimed variance, right? And chi-square is what? Chi-square is test statistics, and the statistics follow chi-square distribution with n minus 1 degree of freedom, right? That is, here we will find the DF, that is the test statistics. The statistics follows a chi-square distribution with n minus 1 degree of freedom, right? So now we will discuss some problem based on this to illustrate this hypothesis. This is the step 2, right? But what will be the step 3? In step 3, in step 3, in step 3, if chi-square calculative, that is chi-square statistics value, is less than chi-square critical value, that is the value obtained from the chi-square distribution table, then it will accept the null hypothesis H naught. Okay, if chi-square calculative, that is chi-square statistics, is greater than chi-square critical value, then it will reject it will reject the null hypothesis, right? So what things we have done here? In step 1, we will determine the hypothesis, null hypothesis and alternative hypothesis. In second step, we will find the calculative value of chi-square with the help of that formula. Then in step 3, we will find the critical value, and if the calculative value of chi-square is less than critical value of chi-square, then it will be accept the null hypothesis H naught. And if chi-square calculative value is greater than chi-square critical value, in this situation it will reject the null hypothesis H naught. Okay, so this is all about the method procedure for the hypothesis testing, right? And this is the chi-square distribution table. From here we will take the value. Okay, so now we discuss a problem based on the hypothesis testing for variance of a normal population. Okay, the first question is all about what? A manufacturer claim that the variance of the lifetime of a type of battery is 36 hours. Okay. A random sample of 12 batteries is tested and the sample variance is found to be 64 hours square. Test at the 5% level of significance whether the claim is valid. Yes, one point should be remembered that in case of variance, the significance level will be split by 2 if it is two-tail test, and it will be not split, it will be as if in the given as a significance level in case of one-tail test. Remember that in case of variance, the significance level will be split by 2 if it is two-tail test, okay, and if it is one-tail test, then it will be not divided by 2, okay. So now here what is given in this question? What is given here? Given sigma naught square, that is claimed variance, that is equal to 36, n equal to what? 12. Okay, what is the s square? S square is equal to the s square is equal to 64, right? And alpha equal to what? 0.05. Okay, so here we will use alpha by 2 because this is the two-tail test, right? So later we will discuss about this. Alpha is equal to 0.05. This is given here. Now in step 1, what is step 1? In step 1, we have to determine the hypothesis. Okay, so what is the null hypothesis? Null hypothesis is h naught sigma square equal to the 36. And then what is the alternative hypothesis? HA, this will be equal to sigma square not equal to 36. So we can see that this is two-tailed test. This is two-tailed test. This is two-tailed test, right? So here the alpha will be split by 2. Okay. So now in step 2, we will find the value of chi-square. So chi-square calculative value, this is equal to the what? Formula n minus 1 into s square by sigma square, right? This is sigma naught square. Okay. Here the sigma naught square is equal to 36 and n is equal to the what? 12. So this is equal to 12 minus 1 into 64, s square is 64 by sigma naught square is equal to 36. Okay. So this is equal to what? Chi-square calculative value, this is equal to the 11 into 64 by 36. So this is equal to 704 by 36 and this is equivalent to 19.56. In step 3, we will find the critical value chi-square alpha n1 minus 1, right? Here will be alpha by 2 because this is two-tailed by test n minus 1. So this is chi square alpha by 2, that is 0.05 by 2. So this 0.25 and n is 12, n minus 1 is 11. So this is the value is equal to the what? Chi square 0.025 11 is nothing but this is equal to, from the chi-square distribution table we can find that this is equal to the 21.92. 21.92. So now in step in step in this step we can see that as chi-square calculative value is 19.56 is less than 21.92, this is equal to the what? Chi-square critical value. This is chi-square critical value. So 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 it will accept the null hypothesis. Means that means the the claim that variance is 36 hours square is valid. Is valid. So this is about the problem hypothesis testing for variance of normal population. Okay. Now we will discuss another problem based on this. A machine is designed to fill the packet with a variance of 9 gram square. A quality control engineer suspects that the machine has become a less consistent. A sample of 50 packet gives a sample variance of 16 gram square. Test at 1% level of significance whether the variance has increased or not. Right? So in this question, what is given here? Given in this question, what is given? Here given that sigma naught square equal to 9, right? S square is equal to, you can see that 16 and n is equal to the 50, right? So now in first step we will determine the hypothesis testing, right? In step 1, we will determine the hypothesis. What is the hypothesis? The null hypothesis H naught is what? Sigma square equal to 9, right? Sigma square equal to 9. And what is the alternative hypothesis? Alternative hypothesis will be what? H1 sigma 1 is not sigma square not equal to the 9. So this is the alternative hypothesis. We can easily see that this is two-tailed test. This is two-tailed test, right? This is two-tailed test. This is two-tailed test. Now accordingly we will solve this problem. In step 2 we will find test statistics value. Test statistics value, that is chi square calculative value. This is equal to the n minus 1 into s square by sigma naught square, right? So what is the n? N is the 15 here. So we will put this value 15 minus 1 into s square is equal to the what? And s square is equal to the what? Here s square is given 16, right? And sigma naught square is given what? This is 9. So this is equal to the what? 14 into 16 by 9. This is equivalent to 24.8, 24.8, 24.89. Okay. So this is the calculative value. Now we will find in step 3 the critical value. Chi square critical value will be what? Chi square, this is two-tailed test, so alpha by 2 and n minus 1. So here alpha is equal to the what? 1%. So we will find the chi square alpha by 2, that is 0. That is 0.0005, because 1 divided by 2, so this is 0.5 by 100, so this will be 0.005 into 14, right? Because n equal to 15. So this is equal to, from the table we can find that this is equal to 29.14. Okay. So here we can see that what is the value of calculative value? Calculative value we have find 24.89. So as chi square calculative value, this is equal to 24.89, this is less than is equal to 21.14, this is chi square critical value. So we can see that this value chi square calculative value is less than is equal to chi square critical value. So so it will accept the null hypothesis, right? It will be accept the null hypothesis. It will accept the null hypothesis. That means, what is that means? That means is that means although the sample variance 16 is higher than 9, the the increase is not statistical statistically significant significant at 1% level. So there is insufficient evidence to to conclude that the machine has become less consistent. The machine become less consistent. Okay, less consistent. So now we'll discuss. So now we discuss another more problem based on the hypothesis testing for a variance. A food processing company uses a machine to fill create boxes. The machine is designed to operate with a variance of 4 gram square in the field weight. Recently, the quality control suspect that the machine has become a less consistent, meaning the variance has increased. A random sample of 20 boxes is taken and the sample variance is calculated at 7.5 grams. Test at the 5% level of significance whether the variance has indeed increased or not, right? So now we will solve this problem, right? Here, what is given in this question? Given what is given? N is equal to the 20, S square is equal to 7.5, sigma naught square is equal to the 4. Okay. So first step, in first step 1 is what? Determine the hypothesis, right? Since since the engineer suspect the variance has increased. This is a right tail test. Okay, right tail test. So first we will take what the alternative hypothesis and null hypothesis, because this is sigma square is greater than 4. So alternative hypothesis, null hypothesis just opposite to this one. So sigma square is less than or equal to the 4. Okay, here the level of significance alpha is equal to 0.05. Here this is one tail test, right tail test, that is one tail test. This is one tail test. So the alpha will be not split by 2, one tail test. Okay, and next step we will find the value of, in step 2 we will find the value of chi-square statistic, chi-square calculative value. Chi-square calculative value, the formula is what? N minus 1 into s square by sigma naught square, right? So n is equal to what? 20 minus 1 into s square is 7.5 by sigma square is what? 4. So this is equal to the what? 19 into 7.5 by 4. So this is equivalent to what? 35.625. Okay. So this is the chi-square calculative value. Now in step 3, in step 3, chi-square critical value. This is equal to what? Chi-square alpha n minus 1. Here chi-square alpha will be not divided by into. Why? Because this is one tail test. So this is 0.05 and n is equal to the what here? N is equal to 20. So n minus 1 is equal to the 19. Right? So n square, this is what? 19. So from the chi-square distribution table, we can find the value of chi-square critical value. Chi-square critical value, oh, that is chi-square 0.0519. This is equivalent to 30.14. Okay. So we can see that as 35.625 is greater than 30.14. So that is what chi-square calculative value is greater than chi-square critical value. Okay. So what is, so it will, so it will reject the H naught. Means what? It will reject the H naught, means at the 5% significance level, the sufficient evidence to conclude that variance has increased. Okay. What is the meaning? It will reject the null hypothesis H naught, means at 5% of significance level, there is sufficient evidence to conclude that the variance has increased. Okay. These are some exercise questions. A coffee dispensing machine is designed to fill the cups with a variance of 9 milliliter square. A manager suspects the machine has become less consistent. A random sample of 18 cups gives a sample variance of 14 milliliter square. So test at the 5% level of significance whether the variance has increased, and another problem is given to you. In our next lecture, we will extend this comparing two variants using the F test, and that will be the super useful in ANOVA and quality control. And also, if you found this helpful, please like, share and subscribe this video, and try to practice the problem in the description and post your question in the comment. And thank you so much for watching, and I will see you in the next video. Thank you. Thank you so much.